Today we are going to understand about capacitor. Capacitor is an important device in electronics. So capacitor, which is passive device. There are two types of device, active and passive. Active device which depend on another device of the electronics, but in passive which is not depend on another device of any electronics device. Okay, so a passive device such as R, L and C. R means resistor, L means inductor and C means capacitor. So this device is not depend on another electronic device, any device. Okay, so it is called passive. But active device which is depend on another one, such as diode. Diode is depend on resistor and capacitor also. Okay, so after that we can do process of forward and reverse bias. Okay, we require RL circuit or RL resistor in clipping circuit, you know that. Okay, so diode is active device but capacitor which is in passive device. Okay, now we see the function of the capacitor. Function of the capacitor is to store the electric energy and give it to the circuit. So what does it mean? Capacitor is an electric device which charges and discharges electric energy by store it and short period discharge it. Okay, so this is function of the capacitor. Okay, so capacitor is block DC and flow AC. Block direct current and flow alternative current. How we can see it? We will see it in shortly. Okay, now another thing about capacitor, this is the structure of the capacitor. There are two metal plates and one dielectric substance. Okay, before we start that, let's see one example of the capacitor. You know that we use aluminum foil to make food hot. Okay, so it makes food warm in it. So it is kind of that only. So if you take a piece of aluminum foil and in the middle which is piece of paper, alright, so you cover the food with the aluminum foil and in the middle which is food. So consider as which is dielectric substance and aluminum foil which is metal plates. Okay, so because of the energy which is stored inside, that's why food become warm or hot. It keep remaining hot or warm. Okay, this capacitor works kind of that only. Okay, so this is dielectric material. Dielectric material means insulator. Alright, and these two plates are metal plates. Alright, so this is the structure of capacitor. Dielectric or insulator such as paper, rubber, plastic, glass, ceramic and more. Alright, so this is kind of insulator. Insulator means this insulator cannot pass electric current or electricity. Okay, now metal which is conductor, it is allowed to pass electricity in it. So metal such as aluminum and silver. Alright, so you know the structure now. There are two metal plate which are conductor and dielectric substance which are insulator. Alright, and there are two terminal, of course, which one is a plus and another one is minus, positive and negative terminal. Now this is the symbol of capacitor. This is the symbol without polarity. Okay, so one terminal can connect with the positive of a battery and another or supply and another negative which another side of the battery. Okay, now another one is polarized capacitor. You can see this curve, which is considered as a negative one, and another side which is positive one. This is the kind of capacitor we use in a practice. The big terminal or long terminal of the capacitor which is positive, or you can say anode one, and the short one terminal which is cathode. Okay, so this kind of capacitor is called polarized capacitor. Alright, so let's see the operation of the capacitor. Alright, you can see here in middle there are substance of dielectric or insulator, and these two are metal. Okay, so when we connect the supply, one side is positive ions and another side which is negative ions. Okay, you can see here this is steady holding ions in two plates, but you know that positive and negative ions gonna be attracted to each other. They positive ions want to go negative side, alright, just because of the EMF, or you can say the electromotive force potential which is force another side. Alright, that's why this positive ion want to travel negative side and attract. Because of attraction, this is going to this side to combine each other. Alright, they want to go, but in middle you know that this is the insulator, so it is repel. Alright, so because of this these ions, positive ions, could not able to pass on this side. Alright, so the positive ions and negative ions keep connect with these metals. Alright, but after some time full charge, or they both metal are fully charged and no accepted anymore any ions. Alright, so you know that when it is fully charged, so at that time this positive charge which is try to repel each other. Alright, and this side is also. Okay, so this it's called fully charged, and that time capacitance comes. So this is the capacity to charge these two metals with ions. It's called capacitance of it. Okay, it's also called Farad, F, capital F. So this structure and this ions trying to move with path. If it's require another path, so it is discharged from that path only. Okay, so let's take an example of it. This is capacitor. Okay, C. Alright, now this is switch. Alright, this is capacitor, this is switch, this is battery, and this is LED. Alright, now we connect the positive and negative terminal to the battery or another source. Then positive charge will collect here and negative collect here. Okay, so till then if this switch is connected here, okay, that time LED will glow. Okay, now we see until it's fully charged, current will not pass through here. Okay, so LED will glow through here, but through the battery LED will glow. Alright, now we see if capacitor will fully charge and we connect with capacitor and disconnect with battery, then what happen? This fully charged capacitor get the path of this. Okay, switch is connected here and this LED will glow from this. Alright, but this fully charged and this switch connect with here, then capacitor will flow the current through this. Alright, so LED will glow again. Alright, so this is the advantage of the capacitor. Without using battery, we can use storage charges or storage electricity to glow LED or another devices. Alright, so this is the main function of the capacitor. We can use storage electricity to operate another devices. Alright, this is the formula or equation of the capacitor. Q means charges, which is C and V. C means capacitance, which capacity of the storage in both metal plates, positive and negative ions. Alright, and V means voltage. Voltage means EMF, the potential which is apply on it, and from that current will flow. Alright, so this is the operation of the capacitor. Now we see the types of capacitor, which is ceramic. Alright, we use the ceramic as a insulator, that's why from that name use ceramic capacitor. This range is μF microfarad up to 10. Alright, and another which is aluminum microfarad, which is up to micro to milli. Okay, millifarad. So this is the main capacitor using in all circuit. Now the application of the capacitor, which are storage device. Of course you know that capacitor are used as a storage device, and another which is coupling as a in a loudspeaker. You know that this loudspeaker which is only pass the analog signal, or you can say continuous wave, not a DC. So as you know, the DC cannot flow because it's fixed ions are there, so it is not flowing, but the alternative to moving. Okay, so it is can move the polarity also. So from negative and positive side of ion can flow. Alright, so another one is clamping. You see the clamping, there are using capacitor, resistor and diode, which is clamping to move the DC level up and down. Alright, so the output of the capacitor is kind of this. I want to comes to the put the positive waveform to the 0. Alright, but it can't, because when the positive half cycle going to discharge, at that time capacitor going to discharge, and that time current will flow, and then it is up to capacitor how the storage is in it. Alright, so it is kind of the waveform of the capacitor. So this is how capacitor work. I hope you understand the concept of the capacitor. Thank you for watching.